All right, so I wanted to record one last example explaining how we can use the conjugate root theorem if it's helpful for people. This is an optional notes video, sort of picking up where we left off if you would like to follow along with it. So our next example will say, asks, what is the equation of the polynomial with roots root 3 and 4i. So if I'm given these two roots of a polynomial and asked to build the equation, I want us to write it in standard form, just for the extra challenge. But what we're going to do is start by building out our possible solutions. So we're going to set x equal to each root, including the conjugate roots. So we can say x equals root 3, and then x would also have to equal negative root 3 because of our conjugate root theorem. And then we could similarly say x equals 4i and x equals negative 4i, again because of our conjugate root theorem. Then I'm going to set each equation equal to 0. So basically move everything onto the same side. So I have x minus root 3 equals 0, x plus root 3 equals 0, x minus 4i equals 0, and x plus 4i equals 0. So now I have 4 factors of a polynomial that I can now FOIL out. So my next step, I'm going to FOIL roots with similar terms. Meaning I'm going to FOIL x minus root 3, or basically I'm going to FOIL the conjugates. So I'm going to multiply x minus root 3 times x plus root 3, and then x minus 4i times x plus 4i. So I'm going to FOIL these out. Again, if you notice that they're conjugates, you do not actually have to go through the whole process of FOILing them because you might recognize the shortcut. So because I'm multiplying conjugates, I can use my difference of squares rule, and I can just skip to writing x minus 3 because the middle terms are going to cancel when I do x squared minus root 3, or x root 3 plus x root 3 minus root 3 times root 3, which is just 3. So if you recognize that shortcut, great. If not, you can go through the steps of actually FOILing that out and seeing how that comes out. Similarly, you can get to x minus 16i squared, and then I replace I squared with negative 1, and I get x squared plus 16. So when I replace my I squared with negative 1, I end up with x plus 16. And look at this, I have 2 factors that I can now FOIL again. So now I'm going to FOIL these new factors. So I have x squared minus 3 times x squared plus 16. And when I FOIL that out, I get x to the 4th minus 3x squared plus 16x squared minus 48. I combine my like terms and I get x to the 4th plus 13x squared minus 48. So I can write my final polynomial equation as f of x equals x to the 4th plus 13x squared minus 48. And there you have it. So that's how you can use the conjugate root theorem to build up the equation of a polynomial. Make sure you write down any questions you have on this so we can go over it together in class.